All right, so the last type of problem we're going to need to know how to do with rational equations are work problems. And work problems are where you have multiple people sort of working on the same task, and you know how long it would take them to work together, and you want to know how long it might take one of them to work, or you know how long it takes them to work alone, you might want to know how long it takes them to work together. So there's a couple of different ways of doing problems like this. Here's my favorite way of doing it. I like to think of this as sort of like the portion method. Now, when I talk about the portion method, what I mean by is that I want to know, what portion of the job a person can get done in an hour. So if we look at the problem up here, it says every year, the junior and senior classes at Hillcrest High School build a house for the community. It takes the senior class 24 days to complete a house and 18 days if they work with the junior class. How long would it take the junior class to complete a house if they worked alone? Now, I said hours a second ago, it could be days, just whatever time period. Now, the idea is that you have seniors that are building a house, and if they work with the juniors, then they would get an amount of time they work together, right? Or at least a portion of the done together. So what I like to think about is, since we have these units in days, I like to think about what portion of the job seniors or juniors would get done in one day. So the seniors could complete the entire job in 24 days on their own. So that means that every day they would get 1/24 of the job done. So I'm going to write 1/24 under the seniors. That's their portion of the job they're getting done. The juniors, we don't know how long it takes them to complete the work on their own. So whatever it would be though, if it was like 10 hours, then they would get 1/10 of the job done. If it was like 27 hours, it'd be 1/27 of the job. So whatever the number of hours is that they could work alone, in 1 hour, they would get 1/10 of that. I know it's kind of a weird thing to say, but of the job done in that day. I keep saying hours, I mean days. All right, now when we're told when they work together, it takes them 18 days to complete the work. So that means in one day, they would get 1/18 of the job done. So now we have a rational equation that we can solve, and we're going to solve that using our normal method. We're going to factor the denominator. Going to build the pool. Toss in the first denominator. Toss in what you need from the second. And if you look at the third, we already have a 2. We need another 3 because we need 2 3s. So that means that's 8 times 9, so that's 72t. Going to multiply everything by the LCD. I'm going to cancel appropriately. That t is still there, by the way. It looks like it got eliminated, but it's not. I'm going to multiply everything that's left. And I'm going to solve for t. So it would take the juniors 72 hours to finish the job by themselves. All right, so pause the video and try the next problem. Set up your work equation. Identify the portion of the job that each pipe could get done in 1 hour. We don't know how long it'll take to work together, so the bottom of that fraction is going to have to be t. Find the LCD, multiply both sides by the LCD, cancel appropriately, multiply the remaining stuff together, solve for t, and be sure to put units on your answer.